All right, geometers, welcome to the first lesson of the year. Our focus for today is going to be on points, lines, and planes, and specifically also on how to apply these for linear measure. So what I'm going to do is start by giving you a very quick explanation of this upside down triangle and what we're intending to get you to understand by that. And so really we're looking at the building blocks of geometry, and the foundation of the building blocks of geometry are actually points, lines, and planes. That's mentioned at the bottom. Those are our undefined terms. And the thing to understand here is that none of these have any actual size. And that's a kind of a strange concept. And so I want you to imagine the following hierarchy. When we think about space, we think about three dimensions. And so I'm going to just squeeze the word space in here. And so space is everything, all points around us, 3D, length, width, depth, or length, width, height, lots of different ways to express it. Contained within space, what we have is an infinite number of planes or surfaces. And what we know about planes or surfaces is that planes or surfaces are two-dimensional. They're flat surfaces. You can move with length and width, but you don't have any depth or any height. Okay, and then if we move down the hierarchy, contained within planes, we have lines, and by definition, lines are one dimension or one direction. They continue forever in both directions, but of course, when we say both directions, it's along the same line, and there's only one dimension. And then at the bottom of that hierarchy, lines themselves are, of course, made up of an infinite number of points. And if you were to follow this hierarchy down, of course, you should be able to ascertain then that the dimensions of a point are zero. They have neither length nor width nor depth. And again, this is the foundation on which we build definitions. And so it's hard to imagine these, but these are our undefined terms because we refer to them as being undefined terms because they don't actually have any size. We use each of these terms in turn to build definitions. We use definitions to write rules and postulates. A postulate is basically just a theorem that we don't really need to prove, and I'll introduce you to one of those today. And then from those, and including the undefined terms, the definitions, and our rules, we build theorems, which we're going to spend some time this semester and next proving. Okay, so that's a quick introduction. Now what we've got is a series of definitions. This really is the starting point for the language of geometry. You do need to know these definitions so that you can speak geometry and you can understand in a theorem that talks about a segment versus a line versus a ray, that there is a distinction. And so we're going to get a little more into that in future lessons, but you need to be able to speak geometry, and that really means you must make sure you understand these definitions. So as I mentioned before, we've got a point. It has neither shape nor size. It just represents a place in space. Down here is space. That, of course, is 3D. And then we build, in this case, upwards, no dimensions, one dimension, two dimensions, three dimensions, and we move from a point through to space. Specifically, we're going to look at some key phrases that we're going to use in today's lesson. One of them is collinear. So if you break that apart, co as in share, linear as in line. And so points that are collinear are points that share the same line, just like these ones, A, D, E, and C. Coplanar, same logic, they share the same plane. An intersection is the set of all points that are shared or in both figures. And so when you have two lines that intersect, they're going to intersect at a point. And we'll get a little more into that in the examples below. Very quickly, a segment is just a subset of a line. It's a piece of a line. And what it has is two defined starting or ending points. And its length is measurable. And finally, we have congruent segments. The key here is to look at the symbol, which is really just an equal sign with the wavy little piece on top. That means congruent. Mathematically, it's the same thing as equal, but later on we'll explain the significance of the difference between equal and congruent. It's important, particularly when we talk about triangle congruency and when we talk about proofs.
Okay, thank you, Mr. Murgatroyd. We're going to move on now and see if we understand these definitions by filling in the blank and completing the last page. So the first fill in the blank says, two lines intersect at A, and we have to fill that in. Well, I want you to use a space over here and go ahead and draw two lines. So we have line number 1, and go ahead and draw line number 2. And what do you notice? The only thing that they share in common that's in both lines is a point. So two lines intersect at a point. Okay, the second one, it says a plane and a line intersect in A, and we have to figure that out. Well, when we draw a plane, so even though a plane goes on and on infinitely in any direction, right? It's like a piece of paper, but it keeps going infinitely, or like the ceiling or the floor of the room, but it goes on infinitely. That's a plane. We draw them kind of looking like a parallelogram. It's a four-sided quadrilateral. We have to show it. We have to draw a plane, so we have to have it have edges, even though a plane does not have edges. And then if we're drawing a line to go through that plane, or to intersect the plane, I should say, then we have it intersect. It's intersecting right here at this point, and then we continue to show that that line is behind the plane. I can't see it, so we make it dotted even though it still exists, and then we could see it again. So if you had a piece of paper and you poked your pencil through that paper, the paper would be the line, or sorry, the paper would be the plane, and the pencil would poke through and you would see it on the bottom, and that would be the line. So a line and a plane intersect at this green part, which again is called a point. Now, if I drew a line contained within that plane, then this is saying that this line is on the plane or in the plane. So every single point on that line would be contained on this plane. So a plane and a line, these are intersecting. This line is just part of the plane. So a line that intersects a plane just intersects it at this one singular point. So I would draw that to help you remember. And the last one is how do two planes intersect. So think about a ceiling intersecting a wall, or two walls intersecting each other, or the floor intersecting a wall. So what are they intersect in? Well, they intersect when you look in a classroom, like a corner or a whole entire side or edge of where the wall meets the ceiling, or where the wall meets the wall. So if we're trying to draw it, I would draw two X's. So here, if I draw an X, it looks something like this. I'm going to imitate that same X below it, trying to make the blue lines parallel because that's one plane and this is another plane. Oops, my red lines are parallel. So I'm doing my best to try to make a parallelogram here if you're trying to draw that on your paper. Okay, then I'm going to connect. So my blue part is a plane, and my red four-sided figure is acting as a plane as well. And where those two X's meet is where the planes intersect. And all of those points where the two planes collide or intersect are creating the point of intersection, all this place right here. Well, remember, these planes go infinitely up, infinitely down, infinitely right, infinitely left. So up, down, right, left. So this, even though it looks like a segment, it doesn't end. So technically, two planes intersect in a line, right? So we have maybe the red plane coming through, intersecting. We have the blue plane, it's intersecting the blue plane. So it looks like that. And remember, if they go infinitely up and down, then the two planes intersect in a line. If you're having trouble visualizing, just again, talk to your teacher, go talk to a geometry teacher, ask some questions to get some help. Okay, continuing on with the definitions. Says use a diagram to answer the following questions. So in these answers here, we're also going to work on our notation because we take off points if you don't write the proper notation. So you have to understand how to notate what a segment, the difference between a segment, a ray, a line, an angle, all these different vocabulary words that you're learning in geometry. So initially it's really detail oriented. So you have to kind of practice it to make sure you're doing your homework and working on proper notation so it becomes fluid to you because it's a language, you know. So 1A says name 3 points of intersection between a line and a plane. Well, anytime you see 2 points, that's a line. Even though FB looks like a line segment, which it is also a line segment, you could make that go infinitely. As long as you have 2 points, there's a line that's created it. So here we have a line here. BC is a line. CD is a line. ED is a line. FG is a line. Any 2 points create a line. So 3 points of intersection between a line and a plane. Well, FB would come down, intersect the plane at B, and then shoot out, which is why I have a dotted line here. And here we go. So 3 points. Well, B is a point where that line would intersect. If I do another one, how about FD? It intersects at D, and then it goes through the plane and pops out over here. So D is another point. Over here we have GH. This is a line. It's below, coming up, poking through the plane here at G, and then coming back out. So G is a point of intersection between a line and a plane. C would be one, E would be one, A would be one. Right? So all of those different would be options. So you could write any of those letters here. If we came down and did FA, right, that would also be a point. I don't know why my marker's not working, so there we go. Letter B, are points H, G, and F coplanar? Well, the definition of plane is any 3 non-collinear points create a plane. So I can connect those 3 points. They're not collinear. These 2 are collinear, but this third point over here, F, is non-collinear. So any 3 non-collinear points make a plane. So yes, points H, G, and F are coplanar. We can draw a plane that contains those points. I could draw this, and it could go on forever, and it wouldn't matter, right? Not necessarily to point B, but that's a plane. Any 3 non-collinear points establish a plane. Letter C, name an intersection between 2 planes. An intersection between 2 planes, well, 2 planes. We have a plane here, plane BCF intersects plane CDF. So these 2 triangles, they're both planes because they're 3 non-collinear points. And where do those 2 triangles intersect? Well, they intersect here at CF. The planes, remember, go on infinitely, so you have to indicate with the line. An intersection between the orange plane and the purple plane would be line CF. You could have also said, you know, the pink plane and the green plane. So CDF and DEF, those 2 planes would intersect at DF. So that's another option. But you have to put a line symbol on top because planes always intersect as a line. So you could name a lot more, you know, B, C, D, E, that's the plane down here, A, B, C, D, E, intersects with B, C, F at B, C. So there's a lot of different answers here. Those are the only 2 answers. If you have a different answer and you're not sure, just ask your teacher to verify it and let you know if what you did was correct. Okay, the last one, name the intersection between line AD and line GH. So line AD is right here. So this is line AD, and line GH is over here. So GH is going through this plane. AD is on the plane, so will those 2 lines ever intersect? And the answer is they do not intersect. So if you're not sure about that, ask your teacher, but it's something called skew lines, which we'll talk about later, but these 2 lines do not intersect.